Hello everyone, my name is Meng Wang. Now I'm recording homework 6 of probability and stochastic process. Let's look at the first question. Given the joint density function of fx equals a times 1 plus xy when the absolute value of xy is less than 1. The first sub-question asks us to find a so that the above defined is a valid joint density function. So first, let's draw the diagram of y and x. It should be a square like this. Because fxy is a joint density function, so the integral of it should be 1. And the range of xy, both of them is from -1 to 1 from this diagram. So from this equation, we can get the value of a is 1 over 4. The second sub-question, are xy uncorrelated? Show your answer. To prove or disprove xy are uncorrelated, we need to calculate the value of c, which equals c is here, which equals exy minus ex times ey. So first, let's calculate exy. Exy is xy times fxy and integral it. The range of x and y are from -1 to 1, and we can get is 1 over 9. And to calculate ex and ey, first we have to calculate fx and fy. Fx is the integral of fx dy, which equals 1 over 2, and fx very similarly also is 1 over 2. And then we calculate ex and ey. We could get both of them are 0. So c equals 1 over 9 minus 0 times 0, which is 1 over 9, and is not equal to 0, which means x and y are uncorrelated. X and y are not uncorrelated. Okay, for the third sub-question, are x and y independent? Show your answer. To prove or disprove x and y are independent, we need to calculate whether fxy is equal to fx times fy. So from the calculation in the second sub-question, we could get fx equals 1 over 4 times 1 plus xy, and fx is 1 over 1 or 1 over 2, and fy is 1 over 2. So obviously this equation does not exist, so x and y are not independent. Then for the fourth sub-question, find the joint density function of x squared and y squared. To get the joint density function, first we let z equals x squared and w equals y squared. The root of this equation it has four groups of roots. First one is square z square w. Second is minus square z minus square w. Third is square z minus square w. The final one is minus square z and square w. And we can get jx1 y1, jx2 y2, and jx3 y3, jx4 y4. All of them is equal to 4xy. So from the theorem, we could get the joint density function of fc is like this, is the value of fxy over the absolute value of jxy, which we could get the final value is 1 over 4xy. So the joint density function is 1 over 4xy. And the fifth question, prove or disprove that x squared and y squared are independent. Like as I mentioned above, to prove or disprove whether x squared and y squared are independent, we need to calculate whether this equation exists. Fx squared and yfx squared, we could get the value is 1 over 2x, and this one is 1 over 2y. And times these two together, we could get the value is 1 over 4xy, which equals to the joint density function. Hence, fx squared and x squared and y squared are independent. Now let's move to second question. Given the information that fx squared equals a when x squared plus y squared is less than or equal to 1 and 0 otherwise. First, find a so that the above defined function is a valid joint density function. It's a valid density function, so the integral of it should be 1, and we could calculate. From this step, we replace x and y with r cosine theta and r sine theta. And theta, the range of theta is from 0 to 2 pi, and for r, the range is from 0 to 1. So the final value of a is 1 over pi. The second question, find ex based on y, ex based on capital Y, ey based on x, ey based on capital X, and exy. First, let's calculate fx and xy. It's very easy to calculate. The final value is 2 over pi square root of 1 minus x squared, and fy is 2 over pi times square root of 1 minus y squared. Ex is equal to x times fx, the integral of it. The range of x is from -1 to 1, so ex, because this function is an odd function, and the range is can be countered. The range of x is symmetrical of y-axis, so ex is 0, and ex based on y is the meaning of it is that the value of y is a given number, and then we calculate x. It equals x times fx based on y, the value, the integral of it. From here, the value of x is from minus square root of 1 minus y squared to square root of 1 minus y squared. Also, x, here, this is an odd function, and the range of it is symmetrical. So the value is also 0. To get e based on capital Y, we just need to replace y in exy with capital Y, hence the value is 0. To calculate ey is the integral of y times fy. So From this step, we could see that gy equals this function is an odd function, so it's also 0. And ex based on y is y times fxy over fx, the integral of it. And the value of y is from minus square root of 1 minus x squared to square root of 1 minus x squared. Y is also an odd function, so the value is 0. Hence, ey based on capital X is 0. Exy is the integral of xy times fx. The range of y is from minus 1 to 1, and the range of x is from minus square root of 1 minus y squared to square root of 1 minus y squared, which is 0. Okay, let's look at the third question. Prove or disprove x and y are uncorrelated. Similarly, to prove whether they are uncorrelated or not, we need to calculate the value of c. C equals exy minus ex times ey, which we could get the value from the second question. It's 0. Hence, x and y are uncorrelated. That's all. Thank you.